Okay, so let's talk circles. So what'd you guys come up with? Barry? What's A? A is 3. Can you tell me why? So the x is -2, right? The y is -3. Let's check that out. So -2, -3, that's correct. What about this number here? What's that have to do with it? Let's hear it. Is it the diameter? Let's see. It's over 1, 2, 3. That means the diameter is 6. Take the square root, so 3. Good. So this could actually be 3 squared, right? Let's check. Let's try another one. So A goes with number 3. What did you guys think about B? 2. So over 1, up 4. Over 1, up 4. Over 1, up 4. And then this would be 2 squared. Let's see if the radius is 2. 1, 2. It is indeed 2. So C, what would C be? I don't even need to look at the center of it. For this one, I see that the radius is 1. So it would have to be this one, number 4. And the radius is 1, 2, 3, 4. I should have done it this way. This one's number 1. This one's number 2. Okay. I told you guys we're going to do good, right? What? Number is equal to is the radius. Okay, I'm going to show it to you in just a little different light. I can't remember what my next slide is. Okay. So before we go here, so here, this is going to be my horizontal shift, right? And this is going to be my vertical shift, just like over and over and over again we've been talking about, right? Since the beginning of the year, that's what we've been talking about, is these horizontal and vertical shifts, and I promised you that we'd be using it a lot, right? So we are. And this is your radius squared. But there's another way to look at it, and let's get good at this, and then we're going to talk about it in just another way. Okay, so get your whiteboards out. I'm going to it's kind of hard to see these graphs, so I'm going to write in the radius. The radius on this one is 1, 2, 3. I'm going to go ahead and pause it. Okay, you guys did awesome. So this one is my horizontal shift is over 5 squared. My vertical shift is down 3. And it really doesn't matter whether you put 9 or 3 squared. I don't even think I need to do the other two. You guys got 100%. It makes you feel smart? That's awesome. I love it. Give me 1 second. I want to talk about one other thing here. That's positivity. It is positivity. There's another way to look at this. Let's just make one up. Let's see here. Don't want that. Give me a second, guys. Alrighty. Okay, so y plus 1 squared equals 16. So this is going to be a shift to the right 2 and down 1, and then my radius is 4. The equation of a circle can also be written like this. the reason I'm telling you this is because this is going to transition well when we start going to ellipses and hyperbolas, because ellipses and hyperbolas look like this. So I'm just going to preview it now. So ellipses and hyperbolas all have a 1 right here. Okay? So what happens is, hold on. So what's happening here is that this is really on the x-axis. We're going out 4. 1, 2, 3, 4. And on the y-axis, we're also going out 4. 1, 2, 3, 4. And that's what makes my circle. Does that make sense? So you can look at it like this, where it's r squared, or you can look at it like this with a 1, and they're both going to be moving in the same direction. I'm sorry, the same distance. Okay, Jay, what were you going to say? Yeah. Okay, Kane. I'm just trying to transition you into ellipses and hyperbolas. It really doesn't matter. Okay? All right, just a little preview. All righty, let's see. What is the distance from Upland to San Clemente? Well, we can see it right here, right? It's 1, 2, 3, 4, 5, 6, 7. It's whatever distance that this grid right here looks like. It says 25. I can't really tell. But depending on what the legend says on this, it looks like from here to here is about 25 miles. So probably 35 miles. I have a reason for this, I promise. But what if I wanted to know to Huntington Beach? Can I count that? You can't do it by just counting on the grid, right? So, what do you mean you can't? That's what I'm going to show you right now. Okay, so instead, I can draw myself a slope triangle, right? It's a right angle. And this distance right here is 1, 2, 3, 4. And this distance right here is 1, 2, 3. Okay. I can't have you guys sitting together if you're going to talk over me. One, 2, 3, 4, 5. So if I square this side and square this side, I get this side. So just like Kane was saying, 4 squared plus 5 squared equals r squared, Pythagorean theorem. Okay? So 4 squared is 16 plus 25 equals r squared. What is 16 and 25? So 41 equals r squared. So what's r then? Well, what's root 41? Can we estimate that? It can be a decimal. 6 point something. Where'd you get that number from? The square root of 36 is 6. The square root of 49 is 7. So 36 and 49, so it's got to be somewhere around 6.5. Sure. So this distance right here is 6.5. And that's all the new learning today. This actually can be rewritten a different way. You guys have seen it before, but I hate to teach it that way, but I'll show you. So this is a squared plus b squared equals c squared, which you guys should have learned in 7th grade, right? But I can also write it like this. True? R equals the square root of 4 squared plus 5 squared, correct? If you look back at this right here, this was my change on the x-axis, right? And this is my change on the y-axis. This is the way we write change in x and change in y. Delta x squared plus delta y squared. Another way to make a change in x is this. X sub 2 minus x sub 1 plus y sub 2 minus y sub 1. Is this looking familiar now? This is the distance formula. So the distance formula and Pythagorean theorem are the same thing. But why would you want to do all that mess when you could just count? Right? I never understood why they torture you kids with this right here, when it just means this. It's just counting. Okay? Alrighty. I think that's enough for you guys to be able to do your homework. Alright, I'd like to see if you guys can tell me the distance of that. Go ahead, on your whiteboards. Work together. 2, 1. Alright, so I think we're still at 100%. So 14 squared plus 4 squared equals r squared. This is 196 plus 16 equals r squared. What'd you get here? 196, 212 equals r squared. Take the square root of both sides, and you guys got approximately 14.5 or 14.6. All right, yeah. How would you get the circle? Well, I can't draw it on here. But basically, that's a really good question. I need you guys to stop talking, please. Okay? So basically, in every direction, I could draw myself a slope triangle, right? So as long as I'm going up 14 and over 4, up 14 and over 4 in that direction, let's do it on something. I think I might have one like. Let's try this one. I'll make one up. So let's say my center's here, and I go down to over 1, 2, 3. Right? If I want to make my circle, I would just do that in every direction. Down to over 3, up to over 3, up to over 3, down to over 3, and that's going to give me a perfect circle. You'll see. See that? So as long as you do the proper slope triangle in all directions, it will give you a circle. Okay? That was a really good question. Anybody else? Okay. All right, so pencils down. Graph the circle after writing the equation in standard form. So the circle there's always, the C stands for the center of the circle. So if my center is at 5, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, and containing the point 8, 6, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6. Oh, look at that's the exact same one that I just did. So my radius is right here, correct? So in order to figure out my radius, the distance of my radius, I'm going to go up 2 over 3 So up 2 over 3 is going to be 2 squared plus 3 squared equals r squared. 4 plus 9 equals r squared. So 13 equals r squared. Now the equation of a circle, if you remember, is x minus h squared plus y minus k squared equals r squared. Well, my r squared is 13, so I already have that piece. My center is over 5, up 4. So if I'm going over 5, that's going to be x minus 5 squared. And then there's my x, and here's my y. I'm going to be going up 4. There's my equation. Pretty easy. So you got to find the radius, and then you just have to substitute in the center. It is squared. 13 is equal to r squared. You don't have to, unless you want to tell me exactly what the radius was. It's 3.6, but I would leave it in this form like this. Kane? Yes. Okay, I believe so. All right, so here's my circle. And if I want to make a proper circle, just like we said before, I would make my slope triangle in every direction. So up 2 over 3, down 2 over 3, down 2 over 3. And that should be a circle. Uh-oh. Alrighty. Questions? Are we good so far? Okay. Let me see what else I have in here. Fun stuff. Try it. I think you guys can struggle through this. Try it. You know exactly what you should be doing. What should you be doing? You got to separate everything, right? And complete the square. So work together on that. You got to complete the square twice. All right, let's see if you did it the way I do it. Okay, so I'm going to move stuff around a little bit. Let's make, so I need my x's together and my y's together. And this 13 just needs to be moved on the other side. So I have x squared minus 2x. I want to complete this square. Then I have the y squared Jay, I want you guys up. I want everybody just paying attention up here. Plus y squared minus 8y. I want to complete that square. Correct? Let's move that over. And then on the other side, Bryce, I need the talking to stop. So I have a negative 13 because I moved it over this side, and I'm going to need to add twice, right? I have two squares over here that I'm going to complete the square, so I better make sure that I add it on the other side as well. So what gets added here? Well, half of 2 is 1, so 1 squared, or I should say negative 1 squared. Negative 1 squared is just 1, so I'm going to put a 1 there. Half of negative 8 is negative 4 squared, which is positive 16. So now I can complete my square here. X minus 1 squared plus y minus 4 squared move this down equals 4. Yeah, we're going to do another one. So I'm going to move over 1 and up 4, over 1, up 1, 2, 3, 4. And then my radius is not 4, but 2, because the square root of 4 is 2. So I go out in each direction too. And I should have a circle. All right, thumbs up, thumbs down. How are we doing? Okay, you guys want another one? Okay. Nathan? Sure, you can take a picture of it. Absolutely. You. Are you ready? Okay. Do you guys want to try one? You guys try one. One. Okay. Even when I was walking around, I saw some of you could go straight to here. Because I know half of 6 is 3. Right? So I was adding not 3, but 9. Right? So I've got negative, when I move this over, change my color. So when this goes over here, let's move our graph over a little bit. It's going to be negative 25. And 3 squared is 9. So I add 9. And then here I've got a y squared. A y squared and a negative 10. So I know that that's going to be y minus 5 squared. And so if it's negative 5, so 5 squared is 25. Which is nice because that makes these two cancel each other. It can be done very quickly, right? I can't hear you. You didn't have to. It is a perfect, you still have to, oh, this one right here, y squared minus 10y plus 25, you're absolutely right. Did you guys catch that? I didn't. Good job, Andrew. Yes. I can't hear what he's saying because you guys are talking. Yes. That will make a difference. Let's talk about that for a second. So x plus 3 squared plus y minus 5 squared looks like this. I don't know if I want to spoil it for you. So we're going over 3, up 5. 1, 2, 3, up 5. 1, 2, 3, 4, 5. My radius squared is 9, so 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. I don't want to spoil it. But that's such a good question. Okay, so this is what happens. If it had a negative sign, so right now my graph is, I would be plotting these same exact points right here, right? Only, instead of making a circle, and so it's all the same stuff, but with a negative sign, okay? Instead of going in, it goes out. The circle kind of splits in half, yeah. I wonder, so remember you guys, I said we could have written it like this, right? I could have written it like that. So here's my next question to you. What do you think happens if these two numbers are different? I heard it. It's going to change the shape of the circle, right? There, now I don't have to teach you the rest of the chapter. Pretty cool, right? I think we're going to do that tomorrow. I think so. I don't know. I haven't looked that far ahead. Yes. Yes. Okay. So you guys ready for your homework? Let's see if I have anything else in here for you. we're good. Okay, so what did you learn today? You guys learned how to graph circles? How about you guys now have a general understanding about the equation of a circle, right? Okay, how is the equation of a parabola similar to a circle? Right? I heard it from Barry. Instead of having just an x squared or a y squared, they're both squared. So if you think about it, guys, when only one of them is squared, what happens is it's like the parabola it's like the circle never closes. Do you know what I mean? But once you square both of them, then it closes the circle. You know what I mean? So it's all related together. Okay? It's like two parabolas, right? Making a perfect circle. Exactly. All righty. I'm going to get you your homework right now. Good job, guys.